Hello everyone, I am Nasir Hussain, currently pursuing computer science engineering at Sri Venkateswara College of Engineering. Today I am going to talk about correlation and regression, Karl Pearson's coefficient of correlation and applications. Introduction to correlation and regression. Correlation and regression are statistical techniques used to analyze the relationship between variables. Karl Pearson's coefficient of correlation measures the strength and direction of the linear relationship between two variables. The coefficient of correlation ranges from -1 to +1, with -1 indicating a perfect negative correlation, +1 indicating a perfect positive correlation, and 0 indicating no correlation. Karl Pearson's coefficient of correlation. Karl Pearson's coefficient of correlation, denoted as R, is a measure of the linear relationship between two variables. It is calculated by dividing the covariance of the variables by the product of their standard deviation. The formula for calculating Pearson's coefficient of correction is given. Interpreting Karl Pearson's coefficient of correlation. A positive value of R indicates a positive linear relationship, meaning as one variable increases, the other also tends to increase. A negative value of R indicates a negative linear relationship, meaning as one variable increases, the other tends to decrease. The magnitude of R indicates the strength of the relationship, with the value closer to -1 or +1 indicating a stronger relationship. The graph is shown. Applications of Karl Pearson's coefficient of correlation. Business and economics. Coefficient of correlation is used to analyze the relationship between variables such as sales and advertising expenditure. Medicine and health sciences. It helps determine the relationship between variables such as age and blood pressure. Social sciences. Coefficient of correlation is used to study relationships between variables like education and income. Strength of Karl Pearson's coefficient of correlation. It provides a standardized measure of the linear relationship between two variables. It is widely used to easy to calculate, making it a practical tool for researchers and analysts. It can be used to identify and analyze patterns and trends in data. Limitations of Karl Pearson's coefficient of correlation. It only measures linear relationships and may not capture nonlinear relationships. It is sensitive to outliers, which can significantly affect the value of coefficient. It assumes that the relationship between variables is constant across entire range of variables. Example of positive correlation. An example of positive correlation is the relationship between study hours and exam scores. As the number of study hours increases, the exam scores tend to increase as well. The positive relationship would be indicating by a positive value of Pearson's coefficient of correlation. The types of positive correlations are strong positive correlation, weak positive correlation, negative, strong negative correlation, weak negative correlation, moderate negative correlation, and no correlation. Example of negative correlation. An example of negative correlation is the relationship between temperature and ice cream sales. As the temperature increases, the ice cream sales tends to decrease. The negative relationship would be indicated by a negative value of Karl Pearson's coefficient of correlation. Example of no correlation. An example of no correlation is the relationship between shoe size and intelligence. There is no clear relationship between shoe size and intelligence, so the coefficient of correlation would be close to 0. This indicates that there is no linear relationship between these two variables. Conclusion. Karl Pearson's coefficient of correlation is a valuable tool for analyzing the relationship between variables. It can help identify patterns, trends, and associations in data. However, it is important to consider the limitation of the coefficient and interpret the result in the context of the specific study or analysis.